Good afternoon, everyone. Now, my name is Nilam Assistant Mathematics Teacher, Kumdini Homes, Kalimpong. Now, today I am going to teach the topic determinant. You might have done matrices. Okay. Now, the determinant is related to the matrices. It is a scalar form of matrix. Now, say first of all, now the matrix. Now, you know about these things. The matrix is represented by the first bracket, curly bracket, and the square bracket. But these are the tabular form of matrices, but the determinant will represent it by the mode. The mode of a matrix is the determinant. If you calculate the magnitude of a given matrix, what you will get? The determinant. Now there are two different types of determinant that you have to do. Determinant means it's a matrix. We'll calculate the magnitude of the matrix. Now in case of determinant, the order of the matrix should be same. Then only we can calculate the magnitude of that particular matrix, and that is called a determinant. Now the order means, let us suppose D is equals to, this is a matrix for determinant form. This is 2 into 2 determinant, A1, B1, A2, B2. This is 2 into 2 determinant. Now this is a presentation of determinant. Now next, 3 into 3 determinant, A1, B1, C1, A2, B2, C2, A3, B3, C3. This one is 3 into 3 determinant. Now, while doing the determinant, you should have a concept of rows and the column. Now, say, this one, in case of 3 into 3, I'll explain. This is 3 into 3. This one is first row, this is second row, this one is third row. And similarly, this thing's column 1, column 2, and column 3. Now, parallel to the earth's surface is considered as row, and vertical to the earth's surface is considered as column. Now, next, it's a theoretical chapter. No formulas, nothing. That you have to use presence of mind, or you should remember the theory of determinant while solving the numericals. Now, let's start with the properties of determinant. First of all, I'll calculate the magnitude of a determinant. Let us suppose the determinant is equals to D, and it is represented by A1, B1, A2, B2. This is 2 into 2 determinant. To calculate the magnitude of this determinant, I'll write mode of D. Next, what you have to do is, you have to multiply the diagonal elements. This is diagonal element. Multiply this to quantity, what you will get? A1, B2, then minus, then off diagonal element this way. A2, B1. This is a magnitude of matrix, and this is called the determinant. Similarly, the expansion of 3 into 3 determinant is A1, B1, C1, A2, B2, C2, A3, B3, C3. This is 3 into 3 determinant. Now, how to expand? This one is very easy. Now, second one, how to expand the 3 into 3 determinant. That you have to consider the element of the rows or elements of the column. Now, here in this case, I'll consider first row. And these are the A1, B1, C1, A2, B2, C2, A3, B3, C3. You have done these things in matrices, the chapter matrices. These are called the elements. Now, over here, A1, B1, C1, A2, B2, C2, and A3, B3, C3 are the elements of determinant. Now, determinant, the element itself has its own sign. If it is plus, then this is plus, minus, plus, plus, minus, plus, minus, plus, plus, minus, minus. Now, determinant element itself have own sign. Clear? Now, I'll expand this element. First row, I'm going to expand A1. If I consider A1, over here we will discuss the condition of minus and the cofactor A1. If I consider A1, if I consider this A1 is positive, then if I consider A1, its horizontal line and the vertical line, horizontal line of A1 and the vertical line of A1, that you have to cancel. Then if you cancel these two quantities, then what remain inside the determinant? B2, C2, B3, C3. Then you have to write these things over here. I already told you that determinant, the elements of determinant have itself is signs. Now, if it is plus means this one is minus B1. If you consider B1, then next you have to cancel its elements of the horizontal row of B1 and the vertical row column of B1. This and this get cancelled. This and this get cancelled. What you will get? A2, C2, A3, C3. Then I will write A2, C2, A3, C3. Plus the next element is C1. This is plus, this is minus, the next one will be plus C1. If you consider C1, then horizontal line of the C1 that you have to cancel and the vertical line of the C1 that you have to cancel. These quantities get cancelled. Then what remain inside the determinant? A2, B2, A3, B3. A2, B2, A3, B3. Now next we'll do the multiplication method over here, what I did over here. Then you have to multiply the diagonal element B2, C3 minus, then this one of diagonal B3, C2. Next minus B1, then again same way that you have to multiply A2, C3 minus A3, C2 plus C1, then same way multiplication A2 B3 minus A3 B2. This is also not equals to 0. This one is the expansion property to calculate the magnitude of determinant. This property is very, very important, and while solving the numericals, I'll use frequently these properties. Clear? First one. Now the second one, second condition, let us suppose this one is first. Second one is, again I am going to consider one determinant. The determinant is A1, B1, C1, A2, B2, C2, A3, B3, C3. Now the second property, according to the second property of a determinant, if you change row into the column or column into the row, the value of a determinant will remain same. If I change row into the column or column into the row, the value of a determinant will remain same. Now in case of determinant, now say, we can change, this one is row 1, row 2, row 3, this is column 1, column 2 and column 3. I did these things over here only. Now if you change row into the column or column into the row, the value of a determinant A1, B1, C1, A2, B2, C2, A3, B3, C3. The value of determinant will remain same. If this equals to D means this one is also equals to D. That means nothing will happen if you change row into the column or column into the row of a given determinant. The value of a determinant will remain same. But whereas in matrices, if you change row into the column or column into the row, such kind of matrices are called transpose matrix. But in this case, the value will remain same. Let us suppose the example, these are the elements. Suppose, let us suppose the magnitude of this determinant is, let us suppose 20. Okay. Now if you change row into the column and column into the row, then again if you use this first property of determinant, again you expand this determinant, what you will get? Answer 20 only. There will be no change. If you change row into the column or column into the row, the value of a determinant will remain same. This one is very, very important property. Now, next property number 3. Now, say another property, if we interchange two adjacent rows or two adjacent columns of a given determinant, the value of determinant will remain same, but the sign will change. That means, if you interchange two adjacent rows or two adjacent columns of a given determinant, and now let us suppose I'll interchange these two quantities. The first column is replaced by the second and the second is replaced by the first. In this case, B1, B2, B3, A1, A2, A3, the third column will remain same, C1, C2 and C3. Now, initially what is the sign of this determinant? Plus. Now, next it will be minus. If you interchange two adjacent rows or two adjacent column of a given determinant, the value of determinant will remain same, but the sign will change. Now, this property, what I did over here, I've used this property in case of column. You can use the same property in terms of rows also. Now, say if I want to interchange these two quantities, then the first row will remain same. If I interchange this two, then this one will be B3, A3, C3, then B2, A2, C2. Now, say I've interchanged these two quantities. Row 2 is replaced by row 3 and row 3 is replaced by row 2. Now, what is the sign? Minus. This one will be plus and so on. Now, the property is, this property is, if you interchange two adjacent rows or two adjacent column of a given determinant, the value of a determinant will remain same, but the sign will change. First one is plus, means if you say interchange, minus. Again, if you interchange, it will be plus and so on. Now, next is the fourth property, another very important property. Next is the fourth property of determinant. Now, according to the fourth property of a determinant, if any two rows or any two columns of a given determinant are identical, the value of determinant is equals to 0. If any two rows or any two columns of a given determinant are identical, the value of determinant is equals to 0. The identical means same. If any two rows or any two columns are identical, let us suppose in fourth property, if I write 1, 1, 1, A, B, C, 1, 1, 1. Now, in this case, first column and the third columns are identical. All the elements are 1, 1, 1, 1, 1, 1. Then directly we can write the value of this determinant is 0. In this case, D is equals to 0. This property is applicable not only in case of columns, it is applicable to rows also. Now, let us suppose the same thing I'll write over here, 1, 1, 1, A, B, C and 1, 1, 1. In this case, first row and the third row is same or identical. Then the value of determinant is equals to 0. Now, this one is important property. Prove without expansion type of questions will use this properties. Now, the fifth property. Let us suppose the determinant is B1, C1, A2, B2, C2, A3, B3, C3. Now, this is numerical based property. Now, try to understand this property. Frequently we will use in numericals. Now, in case of determinant, multiplications takes place only in one row or in one column by any other constant quantity, and with the same constant quantity that you have to divide the numerator. That means, what I mean to say is, the multiplications takes place only in one row or in one column. It's according to the requirement of the numerical that you have to do. Now, let us suppose if I want to multiply this first row by any other constant quantity. Let us suppose the constant is k. With the same quantity that you have to divide this determinant. If I want to multiply this first row by k, then you have to divide the determinant by first k, then multiply the first row. A1 k, B1 K, C1 K. The second and the third rows will remain same. Nothing to do with this two column rows. C3. That means according to the property, once again I will say the property, if you multiply the given determinant or the multiplications takes place only in one row or in one column by any other constant quantity with the same constant quantity that you have to divide the given determinant. Again, once again, if I want to multiply this third column by any other constant quantity, let us suppose q, then I will divide this determinant by q. Then this one will be A1k, A2, A3, then B1k, B2, B3. Now then, only the third column I'll multiply. This one will be C1kq, C2q, C3q. The multiplications takes place only in one row or in one column by any other constant quantity and with the same constant quantity that you have to divide the determinant. In the same way, the common. Now, before doing the property number 7, let me explain the matrices. But in case of matrices, multiplications takes place by any other constant quantity in all the elements, not only in one row or in one column. In all the elements that you have to multiply it by the constant quantity. Now, the third, I'll do this seventh property by numeral 2, 4, 6, 8, 10, 12, 4, 2, 4. Now, see over here. Now, these are the elements in terms of numerals 2, 4, 6, 8, 10, 12, 4, 2, 4. Now, this is also very, very important property for the numericals. Now, say the common can be taken out from, in case of determinant, the common can be taken out from a single row or from a single column. We cannot take one common from all the elements in case of determinant, but whereas in case of matrices that you have to take only one common. But in case of determinant, common can be taken out from a single row or from a single column. Now, say over here. Now, from this first column, common is 2. Over here, the common is 2. Over here also, the common is 2. The total common is 2 into 2 into 2. Now, if I take 2 common from this, this one will be 1, 4, 2. This one will be 2, 5, 1, and this is 3, 6, 2. Or you can take common this way also from the rows. Now, common can be taken out from a single row or from a single column. Now, this much properties are important from the determinant. Now, last property number 8. Now, say this one is the splitting property of the determinant. Now, say over here in the determinant, the first column contains 2 subcolumns. 2 subcolumns are there, A1, A2, A3 is the first subcolumn and the second subcolumn is K, K, K. Now, we can split the determinant into 2 different determinants this way. We can use first, from the first column we can use first subcolumn elements A1, A2, A3. Next, I'll use these things B1, B2, B3, then C1, C2, C3. Or now next subcolumn I'll use this one. Now, what is the sign of K? Everywhere plus, plus, plus. Now, then I'll write plus K plus then K, second subcolumn I am using, then B1, B2, B3. Then C1, C2, C3. This way you can split the determinant into two different determinants. Let us suppose in case of over here minus Q, and minus Q. Then again I can write the sign of Q is minus Q, 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 then B1, B2, B3, C1, C2, C3. Now this way we can split the determinant. Now the theory is over. Now next is the application of determinant. Now next is the application of determinant. Let us suppose I'll consider one triangle over here. Now these are the applications, and from the applications you will get only 2 marks type question. Now let us suppose there are 3 points A, x1, y1, B, x2, y2, and C, x3, y3. If you connect these 3 points, what you will get? This is the geometrical shape of triangle, any triangle. It's a triangle. Now with the help of determinant, we can calculate the area of this triangle. This is the application of determinant, and the formula that you have to remember: area of triangle ABC with the help of determinant is half, then the determinant, then you have to write this coordinates x1, y1, x2, y2, x3, y3, then 1, 1, 1, and I'll use square units. This is the formula to calculate the area of a triangle using determinant. Now, area of a triangle ABC using determinant. And let us suppose all these 3 points A, x1, y1, B, x2, y2, and C, x3, y3. Now, here in this case, now if the 3 points A, B, C lies in the same straight line, means the A, B, C are collinear. You can say these 3 points are collinear. To prove the given points are collinear with the help of determinant, then you have to use this formula. x1, y1, x2, y2, x3, y3, 1, 1, 1. The determinant must be equals to 0. If you get the determinant is equals to 0, then you can say the given points are collinear. Thank you very much. Next class also some numericals.